Okay, finally example number 7. I'm sure if I was in class, this would have been a lot faster. So we are going to graph this function, f of x equals x to the fourth minus 2x squared plus 1. So there's a few things you could talk about the leading coefficient. The leading coefficient is positive, and I'm dealing with a fourth degree polynomial. So I know that my end behavior is going to look like that, where the left and the right are rising. All right, then I'm going to maybe look at my intercepts. So I'm going to say, okay, what if f of x is 0? So I can factor this, I think. What multiplies to give me 1 and adds to give me -2. I think I can factor that into x squared minus 1 times x squared minus 1. It's actually a perfect square when we think of something times itself. And then both of those happen to also be a difference of squares. So I can go further. This is x plus 1 times x minus 1. And then, of course, this is also x plus 1 times x minus 1. So since it's x to the fourth, I would anticipate 4 solutions. And I do have 4 solutions. They just occur more than one time. So notice I have a solution at -1 with a multiplicity of 2. So I could put that point on the graph. I also have a solution of 1 with a multiplicity of 2. And remember, our multiplicity is going to help us know that the graph is going to hit the graph, but then turn around. Now we can also look at the y-intercept. Those were the x-intercepts when f of x equals 0. Now we can look at what happens when I plug in 0. I'm going to get my y-intercept. So when I plug in 0 there, this is just like 0 to the fourth minus 2 times 0. That's all going to be 0 plus 1. So we're actually going to have a point at 0, 1. So if I know the end behavior, and I do, I could at least sketch the graph. I know that this may not be perfect if I'm sketching, but I know it's going to rise on the left. I know it's going to hit -2 and turn around. Well, then I'm going to hit that y-intercept, and then the same thing is going to happen here. And notice I've got 3 turning points, right? Because I know that it is an x to the fourth power, so I can have at most 3 turning points. Now the other thing that you can keep in mind, which we haven't really talked about, is it an even or an odd function? And we looked at that back in chapter 1. So this is actually going to be an even function. And the way that you determine if it's even, I mean, there's a few ways, but mathematically, if you plug in a negative and you get the same function, it's considered an even function. And when it's an even function, remember it has symmetry about the y-axis. If it's an odd function, it's going to have symmetry about the origin, but ours looks pretty good. It looks like we could, of course, get some more points to be a little bit more exact. Like if you wanted to plug in, say, x is 2, then give myself a little bit of space here. You could go and say, okay, my function is f of x equals, it's x to the fourth minus 2x squared plus 1. I'm going to actually plug in a 2. So I have 2 to the fourth minus 2 times, I'm going to plug in a 2 squared. So 2 to the 4th is going to be 16 minus 2 times 4, so minus 8 plus 1. So I'm going to end up with 9. So I could actually be a little bit more accurate if I want to now. And if I'm supposed to be accurate, I should be. So 2, 9, so it's going to go up like that. And then, of course, I can know, because of my symmetry, that other side is also going to do the same. And so it wouldn't go much past those points that you know of. So if you're supposed to be exact, clearly you can be by plugging in some more points. If it's just a sketch, you can get a pretty good idea of what it's going to look like.